In this question, we need to find the shortest distance from the point P whose coordinates are given to the line whose vector equation is given. So this is the line, P is the point, and Q is the point on the line. As we discussed, PQ will be perpendicular to the given line. Hence, we take the dot product between PQ and the parallel vector B to be 0. So in the vector equation, the general equation is written as R is equal to A plus lambda B. So if we compare the given equation with the standard equation, we'll see the parameter lambda is T and the B vector is 3 minus 1. So the B vector, if we write in the column notation, we'll write 3 minus 1. PQ vector, on the other hand, is mentioned by Q minus P. That's the formula, out of which P is already given as 5 comma minus 1. So for P, we'll write 5 minus 1. How do we find Q? Q is a point which is lying on the line, so it has to satisfy the given equation. So the x coordinate will be 1 plus 3t and y coordinate will be 2 minus t. So the Q vector's x component will be 1 plus 3t and the y component will be 2 minus t. And now, since we are supposed to subtract q and p, so q minus p, let's identify the pq vector. PQ vector will be q minus p. So 1 plus 3t minus 5 will be written as 3t minus 4. And for the y component, we'll do 2 minus t minus minus 1. So that will become plus 1, 2 minus t plus 1, which will become 3 minus t. So this is our PQ vector. Now we will take the dot product of PQ vector and the B vector and put that equal to 0. So PQ vector we found just right now, 3t minus 4, 3 minus t. We'll take the dot with the B vector, which is 3 and minus 1. So let's simplify this and put everything equals to 0. How do we find the dot product? The logic is simple. Just multiply the x components together, then the y components together, and then we add them. So 3t minus 4 multiplied by 3 plus 3 minus t into minus 1. On simplification, we should get 90 minus 12 minus 3 plus t equals to 0, which will become 10t equals to 15. This implies t will be equal to 1.5. Let's go back to the question. We were supposed to find the shortest distance. In this diagram, what is the shortest distance? It's the length PQ. So the answer to this question, shortest distance, is we need to identify the length PQ. So for that, you need to identify the vector PQ first, and then we will take the magnitude of it. PQ vector, let's figure out. So PQ vector we had found out as 3t minus 4 and 3 minus t. And the value of t which we got was 1.5. So let's put t as 1.5 in this equation and let's see what do we get. So PQ vector will come out as, so we have a 3t minus 4. So 3 multiplied by 1.5 minus 4 divided by 3 minus 1.5. And if we simplify this, we will get 0.5 as the x component and 1.5 as the y component. So this is the PQ vector. So on the left hand side, let us write down PQ in the ij notation, 0.5 I cap plus 1.5 j cap. Now the shortest distance, remember, was the magnitude of this vector. So that will be square root of x square plus y square. And that's it. If we just simplify this to get an answer, we should get root 10 upon 2 as the answer. So that's the shortest distance for this particular question. A straight line whose vector equation is given and a point Q's coordinates are given. Point P is the point on the line L which is closest to Q. And we need to find the coordinates of point P. So let's have a look at the diagram. We have a line. This red line is the line L whose vector equation is given. And then we have a point Q whose coordinates are also given. Point P is the point on the line closest to Q. So we need to find the coordinates of point P. So we will employ the same logic. Since QP is the shortest distance, QP is perpendicular to the line, which means QP is also perpendicular to the B vector. Hence, we make use of the fact that QP dot B vector will be equal to 0. Now, from the given equation, a B vector is 1, 1, and 2. For QP vector, we will do P minus Q. Now, Q vector is already mentioned to us in the question 11, minus 1, and 3. To find the P vector, all we need to do is figure out the coordinates from the vector equation. So the X component will be 1 plus lambda, Y component will be 3 plus lambda, and the Z component will be 0 plus 2 lambda. So let's write down P vector will be 1 plus lambda, 3 plus lambda, and 2 lambda. And now we need to subtract P and Q to get QP vector. So let's identify QP vector. So QP vector will be equal to 1 plus lambda minus 11, which will come out as lambda minus 10 is the X component. For the Y component, we'll do 3 plus lambda minus and another minus 1. So 3 plus lambda plus 1, which will become lambda plus 4. And for the Z component, it is 2 lambda minus 3. That's the QP vector. Now let's take the dot product of QP vector with P vector and put that equal to 0. So QP vector, which we have found is lambda minus 10, lambda plus 4, and 2 lambda minus 3. We take the dot product with the B vector, which is 1, 1, 2. And we put that equal to 0. Now let's multiply all the components together and then we add them. So lambda minus 10 multiplied by 1 plus lambda plus 4 multiplied by 1 plus 2 lambda minus 3 multiplied by 2 equals to 0. Let's simplify. So we'll get this entire expression. So if we simplify this, we should get 6 lambda on the left hand side, and on the right hand side, we'll get a 16 minus 4, which is 12, which means lambda comes out as 2. Going back to the question, we were supposed to find the coordinates of P, and the coordinates of P are over here, 1 plus lambda, 3 plus lambda, and 2 lambda. Lambda we figured out as 2. So let's write down the coordinates of P will be 1 plus 2, 3, 3 plus 2, 5, and 2 into 2 is 4. So 3, 5, and 4 are the coordinates of point P. Now going to the part B of the question, we need to find a vector that is perpendicular to both L and the line passing through points P and Q. Now take this as a concept. Whenever in this chapter you see the word perpendicular to both, that's a hint we have to use the cross product. So let me explain. Let's revise the concept. So there is a concept. To find a vector which is perpendicular to two vectors, what we need to do, we just take the cross product. So a vector which is perpendicular to both vectors A and B is given by A cross B. So we'll be employing that same logic for the part B. Let's see. In the part B, we have to find a vector which is perpendicular to both L, which is the line, and the line passing through P and Q. Now, the line which passes through P and Q is nothing but your QP vector. And the line L is parallel to 1, 1, 2, which was your direction vector. Let's write down B as 1, 1, and 2. So here we have the two vectors. B is 1, 1, 2, and the QP vector is this, lambda minus 10, all of this. So let's now figure out that particular vector. So B is 1, 1, 2. Let's write that here. So one of the vectors is the direction vector, which is 1, 1, 2, and the other vector is QP vector, which we found out as this. Lambda we found out as 2. So let's put the value of 2 in place of lambda. So what do we get? So QP vector in that case will come out as 2 minus 10 will be minus 8. 2 plus 4 is 6, and 2 into 2, 4 minus 3 comes out as 1. So QP vector is coming out as minus 8, 6, and 1. So write down QP vector, which is the second vector. We write that as minus 8, 6, and 1. Now, since the vector which we need to find needs to be perpendicular to both B and QP, so that vector is nothing but the cross product. So we'll do B cross QP. Let's figure that out. 1, 1, 2 cross minus 8, 6, and 1. And how do we find the cross product? We use the formula, right? So in this case, let's try to use the same logic. So for the x component, we'll have to write 1 into 1 minus 2 into 6, which is 1 minus 12, which is negative 11 as the x component. For the y component, we will write minus 8 into 2 minus 1 into 1, which is minus 16 minus 1, which comes out as negative 17. For the z component, we'll do 1 into 6 minus 8 into 1, which is 6 plus 8, which means 14 is the z component. So this is the cross product, minus 11, minus 17, and 14. And that is the answer to the part B of this question. Just to recap, whenever we have to find a vector which is perpendicular to two given vectors, you need to find the cross product between the two vectors. In this case, it was B vector, which was the direction vector, and then the QP vector. And that's how we got the answer as this. So the final answer we can also write down in the IJK form, minus 11I minus 17J plus 14K.